Okay, let's unpack this. We are diving deep into, well, what you could argue is one of the most crucial bits of documentation out there for enterprise IT. We're talking about the structured design methodology in the Citrix VDI handbook.
Right. VDI, Virtual Desktop Infrastructure. The promise seems simple enough, doesn't it? Give users secure, quick access to their apps, their desktops, their data, any device, anywhere. Sounds perfect.
The ideal digital transformation blueprint, you might say. But the reality,
Yeah.
well, VDI projects often hit snags, they struggle, and the source we're using today, the Zen app and Zen Desktop 7.15 LTSR handbook, it's actually pretty blunt about why.
Oh, yeah, it really is. It flags three main failure factors. And then,
Yeah.
well, they're pretty fundamental.
Okay, so the first one, a lack of clear business justification. If the project isn't really solving a specific business problem, something you can measure, it just ends up being, like the handbook says, just a new complex way to deliver the same old desktop.
Exactly. And that's just expensive complexity, isn't it, for basically no real return. The second factor is not having a structured approach, a methodology. You see teams jumping straight into buying stuff, deploying things.
Classic IT move, maybe?
Yeah.
Skipping the prep work?
Yeah, pretty much. They
Yeah.
skip the homework. And that leads right into the third point, which is a lack of experience and, honestly, confidence within the organization. If you don't follow a process that's proven, the team starts to doubt the design. And then those little hiccups you always get at the start, they suddenly seem like huge disasters.
Right. So we're focusing on fixing that lack of methodology today. We're digging into that five-phase framework: define, assess, design, deploy, and monitor. Our mission here is to pull out the really critical decisions, the ones made during those vital assess and design phases.
Because those decisions, they really set the stage for success or failure. We want to show how VDI is built up like in layers, and the decisions you make higher up about the why, they put limits, constraints on the lower level tech decisions.
Okay, so we'll look at that layered architecture, layer 0, the conceptual stuff, then the user and access layers, layers 1 and 2, right down to layer 3, the resources, and even touching on the control and hardware layers, 4 and 5. So it feels a bit backwards maybe, but the method insists, don't start with the tech, start with assessing, start with the why. Why is it so important to lock down that business case, understand the users before you even think about requirements?
Well, because if you don't do that assessment first, the whole project just gets led by the technology, not by what the business actually needs. The assess phase, it forces everyone to figure out the why, both for the business side and, the technical constraints.
And if you skip it,
You basically have no way to measure success other than maybe, did the computers turn on, which isn't enough. And the handbook, it's really good at giving these strong non-tech reasons why VDI is the answer.
okay, let's get into those drivers then. Because they show VDI isn't just about getting faster machines, like that example of the big financial institution. Their reason wasn't cost or speed. It was, like, survival.
Pretty much, yeah. They were in a city hosting a G8 summit. Huge risks. Employee safety threats, potential civil unrest disrupting everything.
Wow, okay.
So that situation, it demanded instant, massive scaling for work from home. VDI was really the only way they could guarantee business continuity and keep their people safe at the same time. Thousands of employees needing secure access to sensitive systems from home instantly. That's a massive risk they had to mitigate.
That makes sense. It's a powerful driver. Then there's the agriculture example in the handbook.
Yep.
Totally different pressure, right? Thin margins.
Exactly. For them, VDI was purely about the bottom line, financial sustainability. They use virtualization to basically keep old desktop PCs going longer, hardware that was way past its normal refresh date.
So they delayed spending a lot on new hardware.
Billions, potentially. By centralizing the processing and delivering modern apps as services, it kept those old machines useful.
And healthcare, we see that a lot too.
Yeah.
Updates, compliance.
Yeah, absolutely. Imagine having an application suite that needs weekly updates. Security patches, new features, pushing those out to thousands of physical PCs spread everywhere. It's a nightmare. Huge IT effort, potential compliance gaps if one gets missed.
So VDI simplified all that.
Dramatically. Centralized application management, instant, provable compliance across everyone. And these other management goals too, like making IT more agile, being more responsive, or even attracting talent by offering work from anywhere. You need to define all this upfront in the assess phase.
Okay, so the big business why is established.
Right.
Then the focus shifts to the who, the users. Why spend so much time slicing and dicing the user base before we even think about architecture?
Because what the users need, That's the main constraint on your final technical design. You just can't do a one-size-fits-all. If you build the whole VDI environment for your most demanding user, the one who needs everything, you'll end up overspending massively for like 90% of your workforce.
Right. So segmentation is key. The handbook breaks it down across 3 dimensions.
That's right. 3 main ways to classify users.
First one is personalization. How much control do they need?
Exactly. You've got your non-users, think kiosks. Super restrictive, settings are locked down, they can't change anything. Then basic personalization. That's probably most people. They can change their wallpaper, save favorites, tweak a few things maybe, but critically, they can't install software. And finally, complete personalization. These are your developers, maybe engineers, people who need full admin rights to install and manage their own specialized tools within their session.
Okay, that makes sense. Second factor, mobility. Where and how do they connect? This sounds like it impacts security a lot.
Directly. It drives layer 2, the excess layer design. We need to know, are they local, always on the fast internal company network? Are they roaming local, moving between different offices or desks but still internal? Or are they remote, connecting from outside over variable, maybe insecure networks like home Wi-Fi or coffee shops? And then there's the mobile user category, needing some kind of offline access. That's usually the trickiest, and often a smaller group.
And the third dimension, workload. Basically, how much computing power do they need?
Yeah, workload tells you how to design layer 3, the resource layer. We usually break it down into light users, maybe just 1 or 2 office apps, kiosk style, medium running, maybe 2 to 10 apps, some light multimedia like video calls, and heavy users doing intense stuff like video editing, CAD/CAM design, serious data processing, or even software development. They need significant CPU, maybe even GPU.
And when you overlay these 3 things, personalization, mobility, workload, the best VDI model starts to become clear. This is that moment from the handbook you mentioned.
Yeah, it really is. This is what stops you from building something way too complex and expensive. If you look at the VDI model capability comparison table, it's table 7 in the source material, it clearly shows something important. The most common and generally simpler VDI models. Things like Windows apps delivering seamless applications, or hosted shared desktops using a multi-user OS like Windows Server, and hosted pooled desktops, which are non-persistent single-user Windows desktops. These 3 models cover the vast majority of use cases: your light and medium workloads, local and roaming local mobility, basic personalization.
So if most of your users fall into those categories, you probably don't need dedicated personal virtual machines for everyone.
Exactly. Implementing dedicated personal desktops, which are costly and need more management, that's often total overkill. You only really need those more complex dedicated models like hosted personal desktops, or maybe even niche things like local streamed VMs for users who absolutely require complete personalization, or have those intense heavy workloads, or need specific mobile offline capabilities.
Knowing that lets IT focus the budget better, right? Infrastructure for the many. Dedicated resources only for the few who truly need them.
Precisely. Spend the money where it delivers the most value.
Okay, users are segmented. Next up, the applications. It sounds like where things can get really messy. Application rationalization. This isn't just making a list of software, is it?
Oh, definitely not. It's more like a deep clean, a surgical operation on years, maybe decades of accumulated software complexity. The handbook is clear. It's a 2-step process. First, rationalization and cleanup, then linking those cleaned up apps to your optimized user groups.
So what does that cleanup actually involve?
First step, consolidate. If you've got 5 different versions of Adobe Reader floating around or 3 versions of some CAD software, you have to standardize. Pick one version. Just managing images with multiple versions of the same app. That alone can kill a project's efficiency.
Okay, standardized versions. What else?
Second, you need to be ruthless about getting rid of stuff that isn't actually for business. Games people installed, screensavers, maybe old monitoring tools for peripherals no one uses anymore, legacy software that's just sitting there. Every piece you remove shrinks the image size, which reduces resource needs later on.
Makes sense. Retire old apps, ditch the clutter. But the handbook also flags management applications, antivirus, backup agents, patching tools. They need special handling. Why?
Because the whole environment changes in VDI. You can't just run the same backup agent you used on a physical machine on a non-persistent VM that gets wiped clean on logoff. It doesn't work. These management tools, they often need a complete rethink. You need to consolidate them, integrate them with the VDI management platform itself. Maybe you use specialized profile management tools instead of traditional backups, for instance. They're treated separately because how you deploy them is usually unique and tied into the hypervisor or the VDI control system.
Got it. So once the application list is clean and lean, you categorize what's left based on who uses them.
Right, you group them. Common apps stuff everyone uses, like Microsoft Office. Departmental apps used by specific teams, maybe finance or HR software. User apps could be niche tools, temporary software, maybe even some approved personal tools. And then those management apps we just discussed, the redesigned ones. This categorization directly helps you choose the best way to deliver each app.
And that implies you might use multiple delivery methods.
Absolutely. You need that flexibility. You don't have to deliver every app the same way. For common and maybe departmental apps, you might just install them directly into the main golden image. But for others, you might use application streaming, like with Microsoft AppV, or even new techniques like app layering, where the app is packaged into its own virtual disk that gets attached to the VM instantly at logon.
What about really difficult apps like complex design software, maybe things needing special hardware keys or specific drivers?
Yeah, that's where local app access often comes into play. The handbook points this out. It's often needed for heavy CAD tools or maybe intense development environments. Essentially, the application runs on the user's actual local computer, using its power and drivers. But the icon and the window for that app, they appear seamlessly inside the user's VDI desktop session. It feels integrated, even though it's running locally.
Ah, clever. So having these different delivery options, installed, streamed, layered, local access, prevents one problematic app from messing up the whole project.
Exactly. Flexibility is key to handling the diverse application portfolio most organizations have.
Okay, so we've moved from the why in assess to the how in design. This is where the 5+1 layer methodology comes in. And you mentioned this idea of constraints, decisions in higher layers, limiting options in lower layers.
Precisely. You have to follow the flow. We start at the very top, layer 0. Conceptual architecture. This is the biggest, broadest decision. It basically sets the stage for where everything will physically live.
So the main options here, traditional on-premise, right? Where the company manages everything in their own data center.
Yep, that's the classic model. Full control, full responsibility, hardware, software, everything. Then you have public cloud IaaS infrastructure as a service. Think Azure, AWS, Google Cloud. Here, the organization gets rid of managing the physical hardware, the storage, the data center itself, but they still manage the actual VDI software components on top of that cloud infrastructure.
Okay, and hybrid.
Hybrid cloud. This is increasingly common. You've got a single VDI solution, but it uses resources both on-prem and in a public cloud. The crucial part here is that it has to be managed as one single system. That often needs some clever networking and control plane setup so the user experience is the same no matter where their actual session happens to be running.
And the fourth model, the one that really shifts the management load, Citrix Cloud. What exactly does the organization give up control of here?
With Citrix Cloud, Citrix themselves manage and maintain the core access and control layers, that's layers 2 and 4. So things like the director for monitoring, the licensing server, the studio console for configuration, and the critical delivery controllers and site database. Citrix runs all that as a service. The customer's IT team, they only need to manage the resource layer, layer 3 basically, the virtual machines themselves, the images, and the underlying hardware layer, layer 5, whether that's on-prem or in a cloud.
So it significantly reduces the local IT team's operational burden.
Dramatically. Lets them focus purely on the user experience, the images, the applications. But that choice, made right here at layer 0, it really dictates a lot of what comes next in the design.
Okay, let's drill down then. Layer 1. The user layer. This is about the endpoint device and the software receiver the user interacts with. First, big decision. Who owns the device? Corporate versus BYOD. Bring your own device.
Right. And while BYOD looks attractive, saves costs, users like their own gear, the handbook throws in a critical consideration. Desktop loss criticality. You have to ask, how bad is it if this user loses their device, even temporarily?
So if they handle super sensitive data, like in that financial example.
Exactly. Or maybe they're under heavy regulations like HIPAA or SAS 70. In those high criticality situations, BYOD is often a non-starter. You must use corporate-owned, secured, maybe even redundant endpoints. You just can't risk highly sensitive data being accessed from a personal device that doesn't meet security standards and isn't centrally managed or accounted for. The risk is simply too high.
Makes sense. The risk outweighs the convenience. Another layer of endpoint. Repurposing older hardware. We talked about the agriculture company doing this. What's the bare minimum spec to make sure the user experience isn't terrible?
Yeah, you can definitely push hardware past that typical 3-year refresh cycle, save some serious money, but you can't go too low. The handbook suggests a baseline, around a 1 gigahertz CPU, at least 1 gigabyte of RAM, maybe 16 gigahertz of free disk space. But arguably more important is the graphics processing unit, the GPU. It needs to be capable enough to support key HDX features.
What kind of features are we talking about?
Things like basic multimedia redirection, smooth rendering of graphics. If the endpoint is too weak to handle some of that processing locally via HDX, the whole user experience just tanks. It feels slow, laggy. So repurposing is great, but you have to balance saving money with meeting that minimum performance threshold.
Got it. And finally, for layer 1, we need to think about securing those mobile devices, especially with BYD, Unified Endpoint Management, UEM, and Mobile Application Management, MAM.
Yes. UEM is generally about managing the whole device policies, security settings, etc., often more for corporate devices. MAM becomes really critical when it's a personal device, BYOD. IT needs to protect the company data without messing with the user's personal stuff on that same phone or tablet.
How does MAM do that? That sounds tricky.
The key is being selective. AM lets admins do a selective wipe. So if the device gets lost or the employee leaves, IT can remotely remove only the corporate applications and data. The user's personal photos, apps, contacts are all left untouched.
That's crucial for privacy. What else does MAM do?
It controls data flow. This is huge. It can prevent users from doing things like copying sensitive text from inside a secure, virtualized corporate app and pasting it into their personal email or social media app running unsecured on the same device. That kind of boundary control, preventing data leakage, is absolutely essential for modern security and data governance.
All right, now here's where it gets really interesting, as you said earlier. We're diving into layer 2, the access layer. This is the gatekeeper, right? And it's all driven by those mobility and security needs we figured out back in the assess phase. If you mess this layer up, a lot of the security benefits of VDI just evaporate.
That's absolutely right. And authentication is ground zero here. Modern designs, well, they can't just rely on the old faithful Active Directory, or AD. Not entirely. Your design needs to be ready to support federated identity providers. Think things like single sign-on systems or maybe integrating with external partner identity systems. Makes life easier for users and onboarding.
And where the user authenticates depends on where they are, internal versus external.
Correct. The basic logic is pretty simple. Internal users, those local or roaming local folks, they should generally go straight to Storefront. That's the web portal, the front door for the VDI resources inside the network. But best practice dictates that any external remote user must come through the NetScaler gateway. The NetScaler is that hardened appliance sitting at the edge, acting as a secure proxy for all that external traffic.
Okay, and that decision, direct to Storefront or via NetScaler gateway, it links directly to the security policy defined earlier. The handbook has a matrix for this.
Yep, it's a direct mapping, based on the security level required for the resources being accessed. If the business need was just medium security, maybe accessing general company documents, then perhaps basic LDAP authentication, username and password, is good enough. But if the requirement is high security, think confidential financial data, or environments under strict regulations like SAS 70 or HiPay, then the system absolutely must use multi-factor authentication, MFA.
What forms does that MFA usually take?
Typically, it's something like LDAP username password plus a second factor. That could be a physical radius protocol usually, or maybe even requiring a smart card with a client certificate for authentication.
That real-world contrast you mentioned earlier is helpful here. The retail company versus the financial one.
Exactly. The retail example, less sensitive data, maybe customer orders but not financial details. They could probably get away with simple, fast LDAP authentication for their remote users. Easy, low friction. But that financial institution, dealing with highly confidential banking records under strict SAS 70 rules, they had no choice. They had to implement MFA using LDAP plus radius tokens for every single remote connection. See how that initial business assessment in phase 1 directly forced a specific, more expensive technology choice in layer 2. They needed to buy NetScalers capable of handling radius and buy the tokens themselves.
Right, the business need dictates the tech investment. Shifting gears slightly within layer 2, Connectivity. Storefront needs to be highly available, obviously. Users need to be able to log in. The source material warns pretty strongly against some common load balancing methods.
Oh, yeah, very clearly. It basically tells you not to use DNS round robin or standard Windows Network load balancing, NLB for storefront.
Why are they considered risky for VDI?
Because they're not smart enough. DNS round robin just cycles through the IP addresses of your storefront servers. If one of those servers completely crashes, DNS might still send users to the dead IP. Result, logon failure. Windows NLB is a bit better, but it usually only checks if the server itself is up. It doesn't know if the critical storefront services on that server are actually running and healthy. So you can still end up sending users to a server that looks alive but can't actually serve logons, leads to user frustration, help desk calls.
So what's the recommended way?
Intelligent hardware load balancing. The handbook strongly points towards using NetScaler for this too. A proper load balancer like NetScaler can be configured to do deep health checks. It actively verifies that the storefront services are responding correctly before it sends any user traffic to that server. It routes around failed or unhealthy nodes automatically.
Okay, reliable access. That ties into something called beacons, which sounds simple but important. How do they work?
They are simple but elegant. Beacons are just designated websites, one internal, one external. The Citrix receiver software on the user's endpoint is configured to try and reach these beacon sites when it starts up. If receiver can reach the internal Laken URL but cannot reach the external one, it knows, okay, I'm inside the corporate network. So it automatically directs the user straight to the internal storefront URL.
And if it's the other way around?
If it can't reach the internal beacon but can reach the external one, it knows, aha, I'm outside the network. So it automatically knows to send the user's connection request to the external NetScaler gateway address for secure authentication and proxying. It's the simple check that makes the user experience seamless. They don't have to guess or manually choose whether they're internal or external. It just works.
Very clever. Let's focus on the NetScaler gateway itself then. Sizing it properly seems crucial. It's all about secure traffic metrics.
Absolutely, because every single remote connection is going through it, and it's all encrypted using SSL HTTPS. So the two key metrics you have to size for are SSL throughput, how much encrypted data can it handle per second, and SSL transactions per second, TPS, how many new secure connections can it set up each second.
And the handbook notes that the strength of the encryption used actually impacts performance.
Significantly. There are performance curves showing this. If your security policy mandates really strong computationally expensive encryption, like say 3DES, or using very long 2048-bit or even 40 on 96-bit SSL keys, which some high security environments do require, that can seriously reduce the effective throughput of the NetScaler appliance, maybe even cut it in half compared to using older, less secure ciphers like RC4.
So a high security requirement might force you to buy bigger NetScaler hardware or more appliances just to handle the same number of users.
Precisely. That security decision made back in the assess phase or driven by regulation has a direct, tangible impact on the hardware costs in Layer 5. It all ties together.
Finally, for Layer 2, there's a really critical security choice in how NetScaler provides access. SSL VPN versus HDX proxy. It sounds like a major fork in the road.
It is possibly the single most important security decision within Layer 2 for remote access. SSL VPN, the traditional VPN approach, basically creates a secure tunnel, and the user's remote device gets an IP address on the corporate network. It's like they plug directly into the office LAN.
Convenient, maybe, but risky.
Hugely risky, especially with unmanaged BYOD devices. If that user's home PC is infected with malware, that malware now potentially has a direct path into your corporate network. It can try to scan for other machines, attack internal servers, perform DNS lookups, maybe launch denial of service attacks. The device itself becomes an entry point.
Okay, so what's the alternative? HDX proxy.
Yes, the HDX proxy method. This is generally the recommended, much more secure approach for VDI access. With HDX proxy, the NetScaler still encrypts and proxies the connection, but the user's endpoint device never gets direct access to the internal corporate network. It only ever establishes a connection to the specific VDI resources it needs, the virtual desktop or the published application via the NetScaler. The underlying network, internal servers, file shares, DNS servers, they remain completely invisible and inaccessible to the client device.
So it drastically shrinks the attack surface.
Massively. It isolates the potentially untrusted endpoint from the core enterprise network. It's much closer to a least privileged model for network access. Definitely the preferred route for security-conscious VDI designs. Okay, moving up the stack. or maybe down depending how you look at it, to layer 3, the resource layer. This is where the user experience really lives or dies. We're talking about the actual virtual machine image, user profiles, how applications are delivered. If you get this layer wrong, it doesn't matter how good the access layer is, users will hate the system because it feels slow or inconsistent.
Let's hit the biggest pain point first. Slow logins. Everyone hates waiting to get to their desktop. The handbook mentions all the steps that add up. Session setup, profile load, GPOs applying, scripts running. It can easily push past that dreaded 45-second mark people talk about. How do we fix that?
Well, the traditional way was trying to optimize group policies, maybe streamline roaming profiles. But those usually only gave you small improvements. The modern and much more effective solution mentioned is Citrix Workspace Environment Management, or WEM. WEM isn't just about tweaking settings, it actually fundamentally changes how the logon process happens.
How does it change the sequence?
It's pretty clever. It uses agents inside the VM to figure out what's absolutely essential for the user to see their desktop versus what can happen slightly later. So WEM takes all those potentially time-consuming tasks, mapping network drives, connecting printers, running complex logon scripts, and it pushes them into the background. It uses asynchronous processing to run them after the main Windows desktop shell has already loaded and appeared on the user's screen.
Ah, so the user sees their desktop almost instantly, even if things are still loading behind the scenes.
Exactly. The perceived logon time drops dramatically, maybe down to just a few seconds. Even if the total time for everything to finish is still similar, the user experience is vastly improved because they're not staring at a blank applying settings screen.
That sounds like a huge win. Okay, next big thing in layer 3, user profiles. Consistency is king here, right? If settings don't save, users get frustrated fast. The handbook pushes profile streaming hard. Why is streaming better than the old roaming profiles?
Oh, it's night and day. Traditional roaming profiles had a massive flaw. The entire user profile, which could be gigabytes in size, had to be copied from a file server down to the local VM's disk before the user session could fully start. That copy process was often the single biggest bottleneck in logon times.
But how does profile streaming avoid that?
It uses a special filter driver.
Yeah.
When the user logs on, this driver basically tells the Windows OS instantly, yep, the profile's loaded, we're good to go.
Even though the actual data hasn't been copied yet.
Exactly. The system thinks the profile is fully present. But the driver then intercepts requests for files and folders. It only fetches the specific bits of data from the central user store on the file server when the user or an application actually tries to access them. If a user never opens, say, Adobe Photoshop, then none of the Photoshop-related settings in their profile ever get downloaded to the VM during that session.
So it dramatically cuts that initial load time.
Cuts it to practically zero from the user's perspective. The perceived profile load becomes almost instantaneous. It's a massive performance booster.
Okay, but what about consistency if users log into different types of machines? Maybe the Windows 10 desktop one day, then a Windows Server session for a published app the next. Profiles can get corrupted, right?
That's a huge problem, yeah. Windows profile versions aren't always compatible. A Win 7 profile can cause issues on Win 10 and vice versa, or even 32-bit versus 64-bit OS versions. This is where dynamic paths in Citrix profile management become essential. You configure the profile management solution to use special variables within the path where it stores the user's profile. Variables like .ctxosname or .ctxosbitness.
What do those variables do?
The system automatically detects the OS the user is logging into. So if they log into a Windows 10 64-bit machine, the variable might resolve, and their profile gets saved to a path like file server profiles username win10x64. If they then log into an older Windows 7 32-bit machine, it automatically saves or reads the profile from file server profiles username win7x86.
Ah, so it automatically keeps separate clean profiles for each platform the user might hit.
Precisely. Completely automatic segregation. Prevents corruption, ensures the right settings apply on the right platform, all without needing complex scripts or manual intervention. It's crucial for hybrid environments.
Very neat. Okay, last big piece of layer 3. Sizing the virtual machines themselves.
Yeah.
vCPU, VRAM, disk IOPS. This is always a balancing act, isn't it? Give users enough power for a good experience, but don't overallocate and waste expensive host resources. What tools help optimize this, especially density?
We come back to WEM again here. It has specific optimization tools for this. First, CPU optimization. This tackles the noisy neighbor problem on shared hosts. If one user's process suddenly starts hogging 100% of a physical CPU core, potentially slowing down other users on the same host, WEM can detect that runaway process and automatically lower its CPU priority slightly. It ensures fair sharing of CPU resources, keeping things responsive for everyone else.
Okay, keep CPU usage fair. What about RAM?
WEM has RAM optimization, often called memory management. This is really about maximizing user density per host. It looks for applications that are running in a user's session but have been idle for a while. Maybe they minimized Word an hour ago and haven't touched it. WEM can intelligently force those idle applications to release their working set of RAM back to the operating system and ultimately back to the hypervisor.
So that freed up RAM can be used by other users logging onto the same physical server.
Exactly. It effectively lets you squeeze more active user sessions onto the same physical hardware without performance degradation, which directly lowers your hardware costs in Layer 5.
We also need to size the disk space for temporary changes, right? The differencing disk or write cache, especially for non-persistent VMs. What happens if that fills up?
Bad things happen. The VM basically freezes or crashes. Session ends abruptly. Users lose unsaved work. Getting the size of that cache right is critical, and it depends entirely on the workload classification we did way back in the assess phase.
Can you give examples?
Sure. The handbook suggests, for instance, that a typical Windows 10 Lite workload user, maybe just Office apps and browsing, might need around 10 gigabytes allocated for their write cache per session. But if that user is classified as heavy workload, maybe doing software development, compiling code, installing tools, handling large data sets, their write cache requirement could easily jump to 20 gigabytes, maybe even 30 gigabytes or more, just to handle all the temporary files, installers, and application caches they generate.
So underestimating the workload leads directly to storage planning failure.
Absolutely. Accurate workload assessment is non-negotiable for designing the storage aspect of Layer 3 and Layer 5.
We kind of skipped over layers 4 and 5 earlier, focusing on 0 through 3, but the methodology makes it clear they're foundational too. Layer 4 is the control layer, the brains of the operation, you could say. Why is making this layer reliable so critical?
Because if the control layer goes down, the whole VDI environment basically stops working. Users can't get connections brokered to available desktops or apps. Administrators can't manage the environment. It becomes useless. This layer includes those really key Citrix components: the delivery controllers, EDCs, the licensing server, the director server for monitoring, and crucially, the central site database that holds all the configuration.
So redundancy isn't optional here, it's mandatory.
Absolutely non-negotiable. The standard design always requires at least 2 delivery controllers for high availability. They work in an active-active mode usually, so if one fails, the others can continue brokering connections and talking to the database and the site database itself. That needs the highest level of protection. Usually that means using something robust like SQL Server always-on availability groups or clustering or mirroring. It cannot be a single point of failure.
And these control components need sufficient resources themselves, right?
Yeah.
They can't be starved by the user VMs.
Good point. Yes, when you're planning Layer 5 hardware, you have to make sure the control layer VMs or servers are given enough dedicated or reserved CPU, RAM, and IOPS, so they always remain responsive, even when the user VMs are under heavy load.
Okay, that brings us to Layer 5, the hardware layer. The actual physical stuff, servers, network gear, storage arrays that everything else runs on. What are the absolute key performance considerations here that make or break the whole design?
Layer 5 decisions are overwhelmingly driven by 2 things: the need for low latency and high I/O performance, especially from the storage. For storage, the critical metric is IOPS input-output operations per second. VDI workloads are famously brutal on storage. You get these intense bursts of activity, like when hundreds or thousands of users log on simultaneously in the morning, the classic boot storm. And the regular activity tends to be lots of small, random reads and writes all over the place.
Which is why just throwing standard server storage at a VDI project often fails miserably.
Exactly. It just can't keep up with the random I/O demand. You must calculate the required peak IOPS based on your user count, user density per host, and the workload types. And the storage solution needs to be able to handle that peak load consistently, not just average load. Flash storage or hybrid arrays are often necessary. And for the network, latency is the absolute killer.
Meaning the time it takes for data packets to travel.
Yes, especially the latency between the hypervisor hosts where the VMs run and the storage array where their virtual disks live. The handbook emphasizes that the physical network infrastructure, the switches, the cabling, the network cards, must be high speed and low latency. If there's significant delay in fetching data from storage, the user's desktop will feel sluggish and unresponsive, no matter how much vCPU or RAM you gave their VM back in Layer 3.
So the physical foundation in Layer 5 has to be rock solid. Otherwise, all the clever design work in the layers above it is basically wasted.
Precisely.
Yeah.
You can have the best conceptual design, user segmentation, access controls, but if the underlying hardware can't deliver the required performance, The project will fail from the user's perspective. It all has to work together. #tag.tog outro, summary and final thought.
Wow. Okay, so this whole deep dive really hammers home that desktop virtualization. It's not just plugging in some new tech.
Yeah.
It's a serious organizational transformation that demands real discipline across those 5 phases. We saw how starting with the organization's actual needs back in the assess phase, that defined the user groups, cleaned up the applications, and then all that information directly shaped the technical design, layer by layer, conceptual, user, access, resource control, hardware.
Absolutely. The core takeaway really is that methodological discipline. You can't shortcut the process. And success isn't just about the tech. It depends hugely on engaging everyone involved. That structured approach needs to carry through into how you operate and monitor the environment, too. The team structure is just as vital. You need those clearly defined roles. A dedicated project manager, application owners who are responsible for testing their specific apps, business managers who understand the why, and crucially, the service desk team who need to support it day to day.
That tiered support structure sounds critical for making it sustainable long-term.
Oh, absolutely essential. You need that level 1 frontline service desk trained up to handle, say, the most common 75% of issues, password resets, basic connectivity problems. Then level 2 handles the more complex, maybe repeatable technical faults and maybe 20% of tickets, digging into the controllers or storefront logs perhaps. And then your level 3 and 4 experts, they only focus on the really deep, complex 5%, maybe design flaws, core infrastructure issues, vendor escalations. Without that structured support model, even a perfectly designed system can get overwhelmed by operational complexity and user frustration.
Right. Now, we spent a fair bit of time on layer 2, the access layer, authentication, NetScaler, MFA, all focused on securing the connection and verifying the identity trying to get in, rather than just securing the endpoint device itself. That focus seems to point towards a bigger, more modern security concept.
It really does. And the source material even nods towards this evolution, mentioning things like Citrix Cloud and even Zero Trust and related documents. So our final thought to leave you with is this. How does this very structured, layered VDI design philosophy we've discussed, which is so rooted in carefully controlling and securing access, layer 2, and resources, layer 3, how does that inherently set the stage for adopting modern security frameworks like Zero Trust?
Because Zero Trust's core idea is never trust, always verify, right? Doesn't matter if you're inside or outside the network. And the VDI design, especially by forcing external users through that secure NetScaler gateway, by demanding strong policy-based authentication like MFA for potentially every single session, it's already shifted the security focus away from just protecting the physical network perimeter, hasn't it? It's focusing much more on validating the identity and securing the access path for each connection.
Exactly. You're centralizing that control point. You're enforcing granular policies that check the user, maybe even the device posture, the security level of the connection, before granting access to the resource. VDI inherently provides many of the key technological components you need for Zero Trust: the secure gateway, NetScaler, the policy engine, controllers, the integration with identity providers. It moves the whole enterprise mindset away from trusting the network location towards verifying the authenticated session identity continuously. So in a way, a well-designed VDI environment becomes this powerful, maybe even accidental stepping stone towards achieving a fuller Zero Trust security architecture down the line.
A disciplined approach to solving today's problems that also happens to lay the groundwork for tomorrow's security. That's a deep dive.